In this question, we are given if one root of the quadratic equation, we are given p minus q square plus px plus 1 is equal to 0 is twice the other and p is real number, then what is the maximum possible value of q? So we are given here p, q, x square, p. So we have to find the maximum possible value of q where p is a real number. So it's a question of NSAT mock test uploaded in the website NSAT 2026. It's for there. So see, first of all, we have to imagine the two roots of this equation. Given that if one root of the quadratic equation is twice the other, so we can assume that the roots are alpha and 2 alpha. Let's assume the roots are alpha and 2 alpha. So we have to find it like sum of roots, that is alpha plus 2 alpha is equal to 3 alpha is equal to minus b by a. Minus b by a here will become minus p by p minus q into x square. So we have got equation number 1 from here, and now let us see for product. For sum we have already gotten. For product we will get that alpha into 2 alpha, that is the product of roots, is c by a, that is c here is 1 by p minus q. So it is our equation 2. Now I have to simplify equation 1 and 2 and equate the value of alpha. That is, you can see that from here alpha will become minus p by 3p minus q. Sorry, the x square will not come here because we take only the coefficient. And same for here, alpha square will become 1 minus 1 by 2 p minus q. So now do one thing. Now do one thing, you can see, find alpha square from here. So from here, if we do alpha square, it will become alpha square is equal to p by p minus q, and 3 will come down whole square. So here we can get alpha square is equal to, you can see, as we are squaring, then the minus p and p is same, so no need to change the p and minus p. So I am writing it as p by 3 will come down, p minus q, that is whole square will become equal to, you can see if alpha square will be multiplied here, then the 2 will come here to the denominator and it will become 1 by 2 p minus q. So it will become like this, and now we have to just simplify it. So if we try to simplify it, then it becomes like p square by 9 p minus q whole square is equal to 1 by 2 p minus q, and we can cancel p minus q with the square, and from where you can get 2p square is equal to 9 into p minus q. And now we can see that you see here p minus q is in the denominator, so p minus q is not equal to 0 since p minus q is in the denominator, and if p minus q equal to 0, then it will also not be a quadratic, so p minus q cannot be 0. So the equation becomes like this: 2p square is equal to 9p minus q. Now from here we can get the value of q. See, here it's given that to find the maximum possible value of q. So let's find the maximum possible value of q, that is 2p square is equal to 9p minus 9q. From here c implies 2p square minus 9p by minus 9 is equal to q, implies 9p minus 2p square by 9 is equal to q. So we have got the value of p. Now what we have to do is just maximize q. Now see the equation q, the equation that we have got in terms of q, it represents a downward facing parabola, because see the equation, it becomes like this. We can, from here, if we write the equation like this, q is equal to 9p by 9, that is p minus 2 by 9 p square. So it becomes p minus 2 by 9 p square. So it is a down facing parabola, downward facing parabola, the maximum value, and for a downward facing parabola. And you know why it's a downward facing parabola? Because see, before p square we have a negative coefficient, so it is a downward facing parabola, and we have to find its maximum value, that will be here, and the maximum value occurs for a downward facing parabola at x equal to minus b by 2a. So it will occur at x is equal to minus b by 2a. And if we have to calculate minus b by 2a, then it's like minus b, because here from this equation we get minus b. That is, if the actual equation is minus 2 by 9 p square, so minus 2 by 9 it becomes a, and before p there is 1, so the 1 becomes b for this case. So here we have to put x is equal to, you can see, minus b, that is minus 1 divided by 2a, that is 2 into minus 2 by 9. So minus minus cancel, so it becomes 1 divided by 4 by 9, so it becomes 9 by 4. So here we are given that x is equal to 9 by 4, but in this equation there is no x, there is p, so we have to put p is equal to 9 by 4. So q becomes p is equal to 9 by 4 minus 2 by 9 into 9 by 4 into 9 by 4. So 9 and 9 gets cancelled, 2 to the 4, so it becomes 9 by 4 minus 9 by 8 is equal to 8 common, 4 to the 9 to the 18 minus 9, so it becomes 9 by 8. So the maximum possible value of q in this question will become 9 by 8, and it's our final answer.